It's chemistry and you are watching Chem Science.
In this video, we will solve the 9701 Chemistry Paper 42 of A-Levels of the examination series October-November 2022. In this video, I won't be solving the whole paper because it's of 2 hours. So I'll be solving only first few questions of this paper and the remaining questions will be solving in the next video. So let's start with the first question of this paper, that is paper 42 of the October-November series, and here is the first question. Says calcium chloride CaCl2 is an ionic solid and the values of some energy changes are given in table 1.1. Question, there are few values, we will have a look at those values later on. Let's go ahead with the first sub question. Says define a lattice energy. Now what is lattice energy? It's an energy change. It's an energy change when we are talking about an ionic compound, we need to be specific that 1 mole of an ionic compound, 1 mole of an ionic compound is formed from its gaseous ions. So that's the energy change which is called lattice energy. Now here it carries only 1 mark. So we need to be specific about the one sentence. Now let's go ahead with the next question. Before that, let's see here what are we given is the lattice energy of the calcium chloride. We are given the standard enthalpy change of atomization of calcium. We are given the first ionization energy of calcium, second ionization energy. We are given the atomization of chlorine and then first electron affinity of chlorine. This is the information given to us. Now let's go ahead with the next part of the question. Says use the data in the table 1.1 to calculate the standard enthalpy change of formation of calcium chloride, and it may be helpful to draw energy cycle. Show all your working. It may be helpful. It's not necessary that we need to draw, but it is obviously helpful. So I'll draw a short energy cycle here. Energy cycle of what we are talking about. We have lattice energy of calcium chloride and we are supposed to calculate the enthalpy change of formation of calcium chloride. So including these two, we need to form an energy cycle. So suppose if I write an equation for this is gaseous calcium and 2 chloride ions again in the gaseous form, that is going to form calcium chloride in the solid form. Now this is the energy change of lattice energy I have written here. Now we need to calculate the calcium chloride's formation, enthalpy change of formation. So if enthalpy change of formation if we talk about, then we have, let me draw a smaller energy cycle. So I write calcium closer, calcium in the solid form in its standard form and chlorine is in gaseous form in its standard form, and this energy change is the delta H formation, that is enthalpy change of formation, and this is what we have to calculate. And then there is one more energy change here, which is the calcium and chlorine in its standard form is changing into its ions in gaseous form. Now that is called delta H1, which I am naming here. Lattice energy, as we have seen, the value is already given in the table 1.1. We are supposed to calculate the enthalpy change of formation and we need to calculate delta H1, which I have labeled here with the help of this arrow. So let me first summarize what is enthalpy change 1, which I have labeled here. Now that is the summary of so many energy changes in this reaction as the elements are converted into its ions. So first is the atomization of calcium. Then will come the ionization energy 1 of calcium. because the atomization of calcium is going to convert the solid calcium into gaseous calcium, and then the first ionization energy will convert this gaseous calcium into the calcium ion with positive charge 1 positive charge. Now if calcium is 2 plus, then we need to include the second ionization energy also for calcium. So now we have got calcium in a 2 plus state in the gaseous form. Now let's go ahead with the chlorine. Now if we have the atomization of chlorine, according to the definition, 1 mole of chlorine should be formed from its element in its standard form. So this is the equation for atomization. So in this case, if we are using 2 chlorine atoms, then we need to multiply the atomization enthalpy of chlorine with 2. So this is how I'll summarize. And then we need to have chlorine the chloride ion form, that is with -1 charge. So again, the electron affinity of chlorine, first electron affinity of chlorine has to be multiplied by 2 to get 2 chloride ion in its gaseous form, and at the end we get 2Cl minus. So this is how delta H1 will be summarized. So first let's calculate delta H1, and then we will substitute the values into the energy cycle which we have drawn here. So looking at table 1.1 and substituting all the values, I'll write 193 for the atomization of calcium. Then the first ionization energy of calcium is 590 plus the second ionization energy of calcium, which is 1150. Plus the atomization of chlorine. Now the atomization of chlorine is 121. I should multiply that with 2. And again the electron affinity of chlorine is -364. Again that has to be multiplied by 2. So this is how delta H1 will be obtained. Now this gives us the value of 1447. Now if we want to calculate delta H formation, we need to add the values of delta H1 and the lattice energy. That will give us the value of formation of calcium chloride. So the lattice energy given in the table was -2237, and the delta H value is 1447, which ends up in the value of -790. So our answer is -790 kilojoules per mole. So this is the value of the formation of calcium chloride, which we have calculated with the help of our energy cycle and the values given in the table. So let's go ahead with the next sub question, where it says the 3 possible values for the first electron affinity of bromine are shown in the table 1.2. One of them is correct. Place a tick by the correct value and explain your answer. Now I'll tick that it's -342. Why? I'll tell you. The reason is that the electron affinity of chlorine, let's see what was the electron affinity of chlorine was -364 was the value for chlorine. Now as we know that the bromine is bigger in size compared to chlorine. Chlorine is smaller and bromine is bigger. So the electron affinity value should be smaller than the value of the electron affinity of chlorine. The reason being is that it's difficult to attract the electron on the outer shell of bromine, which is farther from the nucleus, and so the energy released will also be smaller in the value. So compared to -364, we'll get a smaller value of -342 and not the bigger value, that is -386. So what I'll write is that the explanation for this is the bromine atom has larger radius, or you can say that the atom is bigger compared to the chlorine. Any one particular reason which is valid can be written with the same meaning. Let's go ahead with the next part, where again it says that the enthalpy change of hydration of chloride ions can be calculated using the lattice energy of the calcium chloride and the data shown in the table 1.3. Now what are we supposed to use is the lattice energy of calcium chloride, and from that we are supposed to calculate the enthalpy change of hydration of chloride ions. Now what are the values given are the standard enthalpy change of solution of calcium chloride is given, and the enthalpy change of hydration of calcium is given. Now the question here is that define the following terms. The first sub question is define the following terms, and the first definition is enthalpy change of solution. Now enthalpy change of solution is the energy change when 1 mole of solute is dissolved in enough water, or you can say a very high quantity of water, enough water to form a dilute solution, Okay, what is next? Enthalpy change of hydration. Hydration is similar to solution, but the only thing is when the ions dissolve. So here again it's the similar, but with only few change in the terms, that is energy change when 1 mole of gaseous ions dissolves in enough water. That is the enthalpy change of hydration. Now the next sub question is, let's go ahead with the next sub question, where again we are supposed to calculate the enthalpy change of hydration using the lattice energy. Now again, if we draw a cycle on the side, then we will say that Ca2 plus in the gas form, 2 chloride ions in the gas form form calcium chloride in the solid form, and enthalpy change of hydration is Ca2 plus in the aqueous form plus 2 chloride ions in the aqueous form. That is enthalpy change of hydration of both. Now this energy change which I have arrowed here is the enthalpy change of solution. So if we want to calculate enthalpy change of hydration, we need to summarize the enthalpy change of lattice and enthalpy change of solution. So let me first write the expression, that is enthalpy change of hydration is equal to enthalpy change of lattice plus enthalpy change of solution. Now if we talk about hydration, that's the summary of both the ions. So summary of both the ions, that is the enthalpy of hydration of calcium and 2 into the hydration of chloride ions, because there were 2 chloride ions involved, and the lattice energy and the solution both, and all are in standard form, so we need to have the standard symbol. Now if we substitute all the values, the value of hydration of calcium is minus 1650 from the table given above, 2 into the value of hydration of chloride ions, and the lattice energy is minus 2237, plus the enthalpy of solution is minus 83. Now if we have substitute all the values and rearrange the equation. then we get an expression something like this, where we have minus 2237 minus 83 plus 1650 divided by 2, and hence we get the value of minus 335 kilojoules per mole. Now you can see that it carries 2 marks. So 2 marks after that is 1 mark for the correct value and 1 mark for the correct expression written over here. Either you write this equation correctly or you write the second equation fully correctly and you get 1 more mark. Even if the last value is wrong, you still get 1 mark if you have the expressions and the substitution written correctly. Let's go ahead with the next sub question E, where it says that calcium fluoride can be synthesized directly from its elements, and the delta H formation, that is enthalpy change of formation, is minus 1214 kilojoules per mole. Predict the sign of the entropy change for this synthesis and explain your answer. Now what the question says is that the calcium fluoride is formed or manufactured from its elements directly. Now if we talk about elements, then fluorine is in gas form and calcium is in solid form, and our product calcium fluoride is again in the solid form. Now if we talk about the enthalpy change, now how is enthalpy change calculated? Enthalpy change is calculated by subtracting the enthalpy, not enthalpy, we are talking about entropy change. So how is entropy change calculated? Entropy of product minus entropy of reactants. Now I'll say that the entropy of product will be less compared to the entropy of the reactants, and the reason here is that there are more gaseous ions on the reactant side. So the entropy of the reactants will have a greater value. So that's the reason that the entropy change is going to end up in the negative value, because the reactant side will have a greater entropy value because of the gaseous molecules present on the reactant side. So the negative value of entropy change we will get, and the reason is that the reactants have more gas molecules. That's the only reason, and that's the entropy of reactant will be greater. Now the next sub question says use the value of delta H formation, that is enthalpy of formation of calcium fluoride, which is given here in E, and use your answer to E1 to predict how the feasibility of this synthesis will change with increasing temperature. We are increasing the temperature. Now let's understand one more part, that when we talk about the feasibility of a reaction, we always think in the terms of the Gibbs free energy change of a reaction, which is given by delta H minus T delta S. Now delta S is the entropy change, T is the temperature, and delta H is the enthalpy change. Now we can see here in this value that the enthalpy change is a negative value. So delta H is negative and T is having some temperature which we will understand later, and the delta S value, that is entropy change value, is again negative for this reaction, which we have already seen here in the first part. So it's a negative value. Now if we say that the temperature increases, now what happens to the second term, the second part of this equation? That is going to be the positive value because of the two negative signs given here, minus T delta S. Delta S is also negative, so that's going to be positive. If the temperature increases, then there are more chances that the delta G, that is Gibbs free energy change, also becomes positive. And the feasibility of reaction is only possible when the delta G value is negative. Only the reaction is feasible when the delta G value, that is Gibbs free energy change, is negative. So what we summarize here is that with increase in temperature, the feasibility of reaction, feasibility of reaction decreases. Feasibility of reaction decreases, or we can say that the reaction becomes less feasible. And we are let's explain our answer also, that because the delta G value may become positive, so the reaction becomes less feasible. And here ends our first question, and let's go with the second question. The second question is about nitrogen monoxide, and that reacts with the ozone. The reaction is given here, NO plus O3 gives NO2 and O2. The reaction is first order with respect to both NO, that is nitrogen monoxide, and ozone at 298 Kelvin, and the rate constant value is also given here. Complete the rate equation for this reaction. Now it's already given in the question that it's first order with respect to both the reactants, so our equation becomes straightway as I'm writing here, with no power because it's first order. Now the next sub question says a reaction is carried out in which the initial concentration of NO and O3 are both 1.20 into 10 power minus 6 moles per dm cube. Calculate the initial rate of the reaction and state its units. So directly substituting the value in the rate equation above, where the rate constant is 11500 moles per dm cube per second, into the concentration of nitrogen monoxide, which is 1.20 into 10 power minus 6, and the concentration of ozone is also the same, that is 1.20 into 10 power minus 6. That gives us the value of 1.66 into 10 power minus 8. And if we calculate the unit, then the rate unit will be moles per dm cube per second. Going ahead with the next sub question, where it is asked that the reaction described in A2 is monitored over a period of time. The reaction which is given here with these values. Predict whether or not the graph of NO against the time, the concentration of nitrogen monoxide against the time under these conditions shows that the reaction has a constant half-life. Explain your answer. We have to predict whether the half-life will be constant for the concentration of NO against time. I would say that it won't be constant, not constant, and the reason is that the values which is both same for which is 1.20 into 10 power minus 6 moles per dm cube for both the reactants. Now that is going to affect because the oxygen is also getting used up, and the concentration of oxygen doesn't remain constant, so the half-life also won't remain constant because the reaction is overall reaction is not first order, So if it's not, overall reaction is not first order, that shows both the reactants are involved, and if both the reactants are involved, the concentration of the other reactant should be very, very high, so that the reaction going on does not affect the concentration of the second reactant. Now if both the concentration, as we know that the concentration of nitrogen monoxide and oxygen is same, so both of them are reacting together, and the concentration of nitrogen monoxide and ozone both is changing, and that's the reason that the overall graph we will not get a constant half-life. Okay, let's go ahead with the next sub question here, where it says that nitrous oxide N2O decomposes into its elements as shown in the equation here. At a high temperature, a small amount of platinum wire is added to a large amount of nitrous oxide here. Now what is written here is that at a high temperature, a small amount of platinum wire is added to a large amount of nitrous oxide, and the reaction follows zero order kinetics. The platinum wire behaves as a catalyst. The first sub-question says that sketch a graph on the axis below of the reaction rate against time for a catalyzed decomposition of N2O under this condition. Now the most important part is that the reaction follows zero order kinetics. It says that zero order kinetics. Now if we are talking about zero order kinetics and we are plotting a graph of reaction rate against time, then the rate does not change with the change in the concentration and with the time, and so because of that we'll get a straight line. We're going to get a straight line, straight horizontal line for the reaction rate graph against time, because the rate does not change because of the zero order kinetics. Fine. The next sub-question says that sketch a graph on the axis below for the concentration of nitrous oxide against time for this reaction. Now as we know that the reaction is zero order and the reaction of nitrous oxide is going to decrease with the time, so the graph will be going downwards, but it's going to be a straight line, not a curve, because it's zero order. If it had been a first order, then it might have gone a curve like this, but as it's zero order, it's going to be a straight line inclined downwards. Now the third sub-question says that the platinum behaves as a heterogeneous catalyst in this reaction. Describe the mode of action of heterogeneous catalyst. Now if we talk about heterogeneous catalyst, platinum is a solid substance and the nitrous oxide is a gaseous substance. So what is the process of the heterogeneous catalyst? So first, the reactant particles or the reactant molecules are adsorbed on the surface of catalyst. You can specify, or you can specify the name of the catalyst, that is platinum, on the surface of catalyst. After adsorption takes place, then the bonds of the reactants are broken. Next, after bonds are broken, the new bonds of the products are formed. And finally the products gets desorbed from the surface of catalyst. This is the process which you have to describe for the 3 marks. Now it carries 3 marks because the first mark you will get for the adsorption of reactants on the surface and weakening of the bonds of reactants and formation of new bonds of products carries 2nd mark, and then finally the products gets desorbed from the catalyst carries the 3rd mark. Let's go ahead with the next sub question, and here question 2. Question 2 ends up here with the 4th sub question says, suggest a reason why this reaction has zero order kinetics when the amount of nitrous oxide is large and the amount of platinum is small. Now what is being tried to explain in the question is that the reaction is zero order only when the platinum is very small and the amount of nitrous oxide is very, very large. So that shows that if the situation, the conditions changes about the amount of catalyst and the reactants, then the kinetics may change, the order of kinetics may change, but here it is zero order. The reason being is that the amount of catalyst is very, very small, and if the amount of catalyst is very small, the active sites of catalyst gets occupied by some molecules of the reactants, and then the further reaction does not take place altogether. So the concentration of the reactants doesn't matter with such conditions. Okay, even if the concentration is changed, it depends on the number of active sites of the catalyst. So what reason we can summarize just in 1 mark? We can't give such a big explanation. So 1 mark says that in these conditions, the active sites of catalysts are occupied by the reactants, and so the reaction is zero order. That is only the one sentence which we can summarize for the whole process. So here gets question 2 over. Question 3 onwards we are going to discuss in the next video.